The volume in liters of 3.8 moles of CO2 gas at STP. Let's talk about some information that's going to help us solve this problem. First off, what's STP? Well, STP is an abbreviation for standard temperature and pressure. And standard temperature and pressure are 0 degrees Celsius and 1 atm. So whenever we're talking about something that takes place at STP, it means that the temperature is 0 degrees Celsius and the pressure is 1 atm. Here's another piece of information that's really helpful. When we are at STP, when we're at 0 degrees Celsius and 1 atm, 1 mole of any gas takes up 22.4 liters of volume. Okay, 22.4 liters, this is like a certain amount of space. And this is how big 22.4 liters is. I made this box here, okay? So if we were at STP and we filled this box up with gas, or we had a balloon that was the size of this box and we filled it up with gas, we would have 1 mole of gas here in these 22.4 liters, okay? So using this information, let's just kind of think through this problem, okay? We have 3.80 moles of CO2 gas, okay? We know that at STP, 1 mole of gas takes up 22.4 liters, okay? So if we had 1 mole of gas, we'd have 22.4 liters. That's how much space it would take up. But we don't have 1 mole. We have 3.80 moles. So we want to multiply this by 22.4, which is the amount of space that 1 mole takes up at STP, okay? This is sort of the method that we use to think through it. Now let's look at how we could solve this using conversion factors, okay? We're starting with 3.80 moles. And now we want to multiply this by a conversion factor that's going to get rid of moles and is going to take us to liters, okay? To do this, we're going to want to take this information and write it as a conversion factor. We could kind of sum up this information as an equation, as an equivalence like this, where we say that 1 mole is equal to or is equivalent to 22.4 liters, okay? And now we have something that really conveniently let us write a conversion factor, okay? There are 2 possible conversion factors that we can write from an equation like this, okay? The first, we'll put this on top and this on the bottom, okay? And it's going to look like 1 mole on top over 22.4 liters on the bottom. Now the other conversion factor that we can write from this is the exact opposite. It's just flipped, okay? So we do 22.4 liters on the top and 1 mole on the bottom. Both of these are completely valid conversion factors. We could use either one of them. But in this problem, we want to use a conversion factor that's going to get rid of moles from the top of this equation. So we are going to want to use a conversion factor that has moles on the bottom. So for this particular problem, we are going to be using this conversion factor, okay? So now we have moles on the top, moles on the bottom. They're going to cancel out, and that's going to leave us with liters. And the math that we're going to do is this times this divided by this. And as you can see, dividing by 1 doesn't really change something's value. So all the math we're doing is this times this, which is exactly the math that we came up with when we were just kind of thinking through the problem, okay? Our final answer is going to be 85.1 liters. We round this to 3 significant figures because there are 3 significant figures here, 3 significant figures here, and this 1 here is part of a definition. It's part of an equation like this, so we don't worry about this 1. It has essentially an unlimited number of significant figures, so we round to 3. 85.1 liters is how much volume, how much space 3.80 moles of CO2 gas would take up at STP, okay? Let's move on. Okay.